You all definitely deserve an update. I know it's been a long time. Life's been throwing curveballs, you know, everything from just about every major appliance in the house deciding to die at the same time. Neighbor's house burning down, my mom having a couple heart attacks, my dad can't take care of himself anymore. It happens. But I've been sneaking out, not necessarily with the video camera, but I've been sneaking out when I can and made some progress on this whole thing. So here's where we're at right now. In fact, we're really close to putting this thing together. So here's what I've done. So you have a couple of discs. They locate on these bosses here. I was going to use pins, but I'm like, wait a second. I've got these in a lathe. They're perfectly trued up. Why wouldn't you do this? So I also used a boring bar here to cut a recess and obviously drill a hole. This was actually kind of difficult to measure. I wanted to make sure the hole was straight. In fact, I started using a drill, and I noticed the drill was traveling off center. Like I could actually physically see it. So I decided to instead bore these out with end mills because that's, you know, I don't have a boring bar quite that small. So having said all that, I drilled a hole right through the middle of that and then used, this height gauge right here, height gauge. Put it up on a 90-degree block, on a granite block, and, use the height gauge to determine that this side of the hole was exactly centered with the bearing race right here. And it turns out it was, much to my surprise. Like I said, I'm glad I caught that. But anyway, so this becomes the motor mount plate. So what I need to do is drill 3 M6 holes and tap them. But this locates itself this way. And this is the actual motor mount plate. They all turned out actually really quite nice, I have to say. The only mistake that I really made was one of these holes is countersunk too deep by 1 millimeter. They're 4.5 millimeters countersunk. And you'll notice that the holes are not centered in the countersink. It's because I countersunk them with an end mill, and the two sizes I have, I don't have a 5/16 end mill, which would have worked. I have a 3/8, so that's what I ended up using. But anyway, so same thing here. There is a registration lip right here that goes into this very small section right there. And you can see, if we're lucky, that it's all nice and perfectly centered with everything. So this then screws onto here. I wanted to say something about this motor. Okay, when I first tried, these are supposed to be standard M4 screws. When I first tried to put them in, they were really, really tight. And then I realized that, hey, wait a second. I bet they cut these threads without taking into account the growth from anodizing. So I ended up having to run a tap through these threads, and once I did that, then the M4 screws went right in. But in order to do that, obviously I didn't want to do it right and let the shavings drop into the inside of the motor. So what I did is actually took this front plate off. And that's when I found a bunch of interesting stuff about these. They look great. The CNC, housing and the end caps and everything look fantastic, but they're not terribly precise inside. The bearings are literally the cheapest bearings money can buy. They're not rated for 50,000 RPM. They're rated for something like 36,000 RPM, I believe. The clearance for the rotor was actually just ground out by hand. Looks like with a die grinder. It was a little sketchy. And then, of course, we had the issue where these threads are not actually right. But all that's fixed. I was just a little bit disappointed to find that out. So this plate attaches to the motor. So I'm going to do this in real time so you guys can see how this fits together. I'll probably speed this up in post. So that's basically how it screws together. Let's see if I can get that nice centered and focused. And you probably can't make it out, but this is the one that's a millimeter low right there. Probably hard to see with all the reflective surfaces. But anyway, so the set screws here just clear the bore. It's a nice, rather snug fit. So the set screws actually don't even have enough room to back out fully and disengage the shaft, which is kind of nice, but this is nice and clear and spins just fine. And again, we would register this. We're using that step onto here. There is literally no play side to side on that. I'm going to drill 3 M6 holes, 1, 2, 3 in a triangular pattern to attach this to this. This, by the way, turned out to be surprisingly flat. I was going to mill it, but I decided not to. So then this just drops in like that and registers, and this will also have 3 M6 bolts in a triangular pattern, and that's basically what you end up with. Everything is nice and positively located. It can't move. And the best part is, it's right dead nuts in the middle. And obviously we have our shaft here with the bolt that we drilled and tapped, and that goes right in there. And that's basically what the drive is going to look like. Just like that. So again, not a whole lot left to do, but I do need some ideas from you guys. So here's what I need. One thing, I found bearings. Actually, they're the exact replacement bearings for these. This is an outer shell from the original bearings. I found these bearings. They're actually affordable. I won't put them in. Obviously, there's the spring washers that go in underneath. There's, I think, 1 or 2 of these guys. But the ideas I need are, I have not been able to locate a bearing for a reasonable price that can take 50,000 RPM in this size that's sealed and pre-lubricated. Those types of bearings do tend to have a lower max RPM. So what I need to do is figure out some way to lubricate these bearings with the shaft in position. And I don't know how to do that. So I've been thinking, you know, little sprayers. It really isn't going to be, it's probably going to sit right there. So there's not a whole lot of room on the around it. You can tell based on, you know, that's an approximate location, but there really isn't a whole lot of space for that. So, you know, maybe little nozzles, if anything that can generate an oil mist, I'm open to ideas there. That's one thing that I need to figure out because, you know, hopefully by this weekend, all this stuff will be able to be bolted together. I'll just have to order the bearings and the front seal and the O-ring seal that goes along this surface. So, and then we'll be ready to put it together and test it. The other thing I need input for is the electronic speed controller, the ESC. This is a 6-pole motor. I've been looking around. I've been trying to find an ESC that has at least a 300 amp capability because I would love the flexibility of blasting this thing with a little bit more juice if possible. I like to have headroom because, you know, as we've discovered with Chinese things, they tend to, for the most part, be a little optimistic in their ratings. So I don't want to be pushing that and having voltage drop issues or whatever it, you know, translates to in an electronic speed controller. So I'm open to suggestions. Please post that down in the comments. And the same with the solution on how to get a mist to the bearings. I will say this about the mist to the bearings issue. I spoke with an engineer at Timken about this, and he said you don't want too much oil. Too much oil will cause the bearings to actually slide in the races. So we don't want to do that. We want something that will just generate a light mist periodically. I've thought about fuel pumps feeding a nozzle, you know, like a small EFI fuel pump feeding a nozzle. I've thought about using, you know, math to figure out a way to use boost pressure on a larger piston surface to act upon a smaller piston surface because you don't need a lot of volume. That's the one thing. We need very, very little volume. That's another option. You know, maybe even a manual thing. Maybe it's a drip type thing, but then that would, you know, obviously limit your mounting options. It would have to be vertical, but it would be dripping all the time too, so that's not really a good option. Another thing I thought about was a solenoid control deal with that took CO2 cartridges, possibly, because again, it's a very small volume of oil. So if you have any ideas along those fronts, please post them down in the comments below, and I'm going to go hide this weekend and finish this up, at least what I can finish up. And thanks for watching, subscribe, and there's more to come.